Welcome to this demo session where the Protecto's DeepSight's capability in terms of detecting the sensitive PIs will be demonstrated. Before we jump into the demo session, let's quickly understand the context of PI detection. In today's AI world, autonomous AI workflows, they dramatically increase the enterprise PI exposure surface. Agentic AI systems process sensitive enterprise and customer data at scale. What this means is the AI agents that can connect to external third-party APIs or third-party systems, databases, third-party LLM providers fundamentally amplify the downstream PI exposure risk because they operate at scale without any human intervention. What is the impact? Straightforward. One missed PII could lead to GDPR HIPAA compliance issues. Critical that sensitive PIs must be detected, sanitized before they reach the downstream LLMs or third-party APIs or third-party systems. One missed PII can escalate into a compliance, security, and a trust incident legally. So we understood the context of PI detection, why it is needed. Let's see how the PI detection has happened. Fundamentally, the NER-based PI detection model was the starting point where straightforward RegEXP-based, rule-based, pattern-based rules were used to identify or detect the structured PIs like phone numbers, credit card numbers, emails, and so and so. And the NER evolved into a NER, little more sophisticated NER model-based PI detection where the NER can identify the PI entities based on the training data. The NER operates on a fixed entity ontology. What that basically means is whatever the PI entities it has been trained to detect, it can detect it. What happens to the new PI entities? It cannot detect it unless it is retrained with a new set of training data. This has been the bottleneck in terms of NER-based PI detection. It requires retraining for new PI classes or PI entities. Retraining for new PI entities, retraining for new entities in new languages. Everything adds a lot of overhead. That has been the bottleneck in terms of for NER-based PI detection. And LLM-based PI detection overcomes all these issues that are seen in NER-based PI detection. LLM-based PI detection doesn't strictly follow the rules to identify or detect the PIIs. It essentially looks at the context and then identifies the PII. If there are any new PIIs to be detected, no expensive overheads in terms of retraining the model with data for identifying the new PIs is required. A simple system prompt fine-tuning kind of a thing will make it flexible and will make it detect the new PIs easily. And since it's operating on a context awareness perspective, I can detect the partial or fragmented PIs much more efficiently, where the NER-based PI detection is most likely to fail. And we can say that NER is pretty sensitive to the format. Any format drift is the NER is going to leak that PI. Whereas LLM-based PI detection is highly resilient to noisy and multilingual data, and any format drifts, this will accommodate and still flag that as a PI. While there are plenty of advantages of LLM-based PI detection we can see over NER-based PI detection. But in terms of latency, NER excels, and in terms of compute efficiency, NER excels. So essentially the modern architectures basically combine these two approaches, NER-based detection and LLM-based detection, and a hybrid architectures basically give the best of both the worlds. And for the demo purpose, let's use the most popular Microsoft Presidio as a reference, and we'll compare the PI detection capability of Protecto's DeepSight against the Microsoft Presidio. You will see the PI detection capability of Protecto's DeepSight in contrast to the most popular open source NER-based model, Microsoft Presidio's PI detection capability. The UI that you see on the screen is essentially an in-house built tool by Protecto just for demonstration purpose. The actual commercial product for sale is DeepSight API stack and not the UI. On the left side of the screen, you can see the NER-based PI detection is there. Microsoft Presidio tool is used for that. On the right side, you can see Protecto's DeepSight PI detection capability. And once you give a prompt and then do a compare PI detection, this UI basically shows the PI detection live by using the APIs, and then it shows you the result. What is special about this query? The name John Smith has typos in it. It's not O, it is 0, and in Smith it is not I, it is 1. So essentially this is a typo scenario where the LLM-based detection, the DeepSight's Protecto DeepSight was able to still detect the person's name as a person PAI, even though there are typos in it. This shows the resilience of Protecto's DeepSight PA detection, whereas Presidio failed to detect the name with typos. Let's move on to the next one. The customer social security number was split. First 3 digits, last 3 digits, 4 digits, verify. Let's run it. And as you can see, Presidio was not able to detect any PAs in this query. However, DeepSight detected SSN with the data for 2 parts. One is 078, first 3 digits, which is a sensitive information, and the last 4 digits of the SSN, again the sensitive information. We don't want this information to leak, though the information is fragmented. Protecto's DeepSight basically detects them and masks them. Let's go to one more query and run the PA detection engine. And as you can see, Presidio has not detected anything in this query, whereas Protecto's DeepSight has found the email. What is special about this query? The email ID is not written in the standard form. Rather, it has been written in a non-standard form, basically verbally writing the email. So these are some situations where there is a format drift for whatever the reason it may be. And even when there is a format drift, DeepSight detects it properly, detects the PA and masks it. Whereas Presidio is not that resilient. Let's take another scenario and running the query. As you can see, 2 PA entities detected by Presidio, and both of them are related to date time. But the name John, not the name, the email johndoe@gmail.com is not flagged as a PA, though it is. But the way the email has been written, it is obfuscated, purposefully written in an obfuscated way to confuse. But DeepSight is not getting cheated by the obfuscation, and it properly catches hold of the email PAI. Let's take a case of multilingual query. This query essentially is a bilingual query containing Japanese and Arabic information containing PAIs. And as you can see, Presidio has detected only person and a driver's license, while the number is not a driver license. The 993771 is a insurance number. Okay, here you can see Protecto's DeepSight has detected a lot of PA entities: MRN, insurance number, driving license number, vehicle identification number, vehicle registration number, insurance number, so on and so forth. So this just shows the capability of Protecto's DeepSight in terms of how versatile it is when it comes to detecting the PAIs across multiple languages. Let's take one more query and run it before we conclude this demo session. And you can see that only one PA entity is detected as person by Presidio, and here person detected in 2 places from the query. Let's look at the query. Rose used Rose as the recovery keyword because Rose remembered it from their anniversary. You can see the word Rose has been used as a person's name in a couple of places and as a flower's name in the second occurrence. And DeepSight essentially detected the PA wherever it is mentioned as a person and masked it because it is sensitive information. Whereas where it is used as a flower, it has not masked it, it is not considered PAI. Whereas Presidio has failed to mask the first occurrence of Rose, which is the name of the person. So this summarizes the demo session where the LLM-based detection, Protecto's DeepSight's capability in terms of detecting all the PAIs with great accuracy is demonstrated over popular, commonly available open source Microsoft Presidio's capability. Thanks for your time.